Rational Functions Part 2, Removable Discontinuities. If you haven't watched the video Rational Functions Part 1, where we discussed the domain of rational functions as well as vertical asymptotes, I recommend that you go back and watch that now, because we will need some of that information to understand what we're doing in this video. Well, let's take a look at the function f of x equals x over x minus 2 times x plus 3. Recall that our domain, which I'm calling this big D, is everything except for negative 3 and 2, because we cannot divide by 0. So we can make a number line, but we got to break our number line up at negative 3 and 2. And that's our domain. Now let's plot our vertical asymptotes. We have our vertical asymptotes, which I'm going to call VA, vertical asymptote, at x equals negative 3 and x equals 2. So we'll put them in here. Now, the last video, we did not draw the graph. In this video, I will, but I'm not going to talk about how to. I would just use some sort of computer system to graph it for us. And I'm going to use Desmos. I like Desmos a lot. I use it a lot. They do not pay me anything to mention their name. I just like using Desmos. And if I graphed my function in Desmos, it would look like this. The most important part for now is that I do have the vertical asymptotes. Now, Desmos in most places won't actually graph the vertical asymptotes. They'll just leave a space there. But I like to put these dashed lines so I know where they belong, like a guide to help me graph or to help me draw the graph. So I would like you to try this next one. Consider the rational function g of x equals x squared minus x minus 6 over x squared plus 7x plus 10. In just a minute, I would like you to pause the video, and I would like you to find the domain, the vertical asymptotes, and then I would like you to draw the graph by hand, no computer system, but not the entire graph. I just want you to plot the vertical asymptotes. Once you have done that, once you think you have an answer, I want you to go back and use a computer system to then go in and graph it to see if you got your answer, that is, if you got your vertical asymptotes correct. So I will give you time now to pause the video, and I will come back in just a bit. Here's my attempt. I know that the domain is when the denominator does not equal 0. That is, it's everything except for when my denominator, which I will factor right here, equals 0. So my domain is everything except for negative 5 and negative 2. And now I'm going to plot my vertical asymptotes, at least what I think the vertical asymptotes are. Let me move that over just a bit. I think I should have vertical asymptotes at x equals negative 2 and x equals negative 5. Now I'm going to go ahead and graph this. I'll use Desmos and see if I'm correct. And I'm not. This is what I get for g of x. What happened? Did I mess up when I factored it? Well, no. Let's go back and check. No, I did that right. So why is there no vertical asymptote at x equals -2? I thought that there would be a vertical asymptote whenever we divide by 0. Well, there's one thing we need to do here that we haven't done before, because we haven't needed to in the problems I've chosen, and that is we have not factored the numerator as well. So if I were to factor the numerator, I would get x plus 2 times x minus 3. Do you see what happens? And I'm pretty sure you do. We see that this x plus 2 in the numerator cancels the x plus 2 in the denominator. That is, I'm supposed to have a discontinuity at x equals -2. My domain is correct. But I've sort of removed it. Really what I've removed is my vertical asymptote. So there's a removable discontinuity at x equals -2 because the factor in the numerator canceled that particular factor in the denominator. If you have studied this before, you have probably called this a hole. Instead of a removable discontinuity, the fancy term, we often call these things holes. Now there is a vertical asymptote, VA, at x equals -5, because there is no factor in the numerator that will cancel or remove this discontinuity, if you would, this vertical asymptote, in the denominator. Let's do a little bit more analysis of our hole. I already know that it's at x equals -2, but I can also find the y value for the hole. And I can find it by plugging in the x value, -2, into my original function, but without the part that got canceled out. That is, if I plug in x equals -2 into what's left over, I get -2 minus 3 over -2 plus 5. And that's the g, or the y value, of the hole. So the graph would look like this. Now sometimes, or very often, you cannot see the hole when using a computer system. You have to know it's there because it's infinitesimally small, but we like to draw it big so that we can see it when we're doing these graphs. Well, let's take a look at another function. And I'm going to factor this one just to make it a little bit easier for ourselves. What if I have the function h of x equals x minus 2 times x plus 4 over x minus 3 times x plus 4. Without using a computer, do you think this function will have any vertical asymptotes? If so, where and how do you know? Do you think this function will have a hole or holes? If so, where and how do you know? If you said there's a vertical asymptote at x equals 3, you would be correct. If you said there is a hole when x equals -4, you would be correct here as well. Now, why is a vertical asymptote at x equals 3? Well, we cannot divide by 0. But why is there a vertical asymptote and not a whole? It's because there's no factor in the numerator that will cancel this particular factor in the denominator. So we have a vertical asymptote. Why is there a whole at x equals -4? Well, I can't divide by -4, so it's outside of my domain. But there is a factor in the numerator that's canceling that particular factor in the denominator. Meaning instead of a vertical asymptote, we will have a whole. Now, what is the y value at the whole? We can find it simply by plugging x equals -4 back into h of x, ignoring the part that canceled. So if I plug in x equals -4 into the top, I get -4 minus 2 over -4 minus 3. And I get the whole -4 comma 6/7. What if we were to graph this one? What do you think this would look like? That is, how much of this do you think you could graph without using a calculator? If you would like to give it a try, feel free to do so right now. And then use a calculator to confirm. I'm going to set it up. I know that there's a vertical asymptote at x equals 3. I know there's a horizontal asymptote at y equals 1. You don't need to know why now. That'll be my next video. And I know that there is a whole at the point -4 comma 6/7. So slightly below 1. Based on some other things that we'll talk about later, also in a later video, I can fill in the rest of my graph. And it might not be perfect, but it's close enough to give me a good idea. Now, what's probably wrong, and I know it's wrong, is that I did not get my y-intercept correct, and I did not get my x-intercept correct either. It really should be shifted over a little bit like this. But for now, I just want to get the general feel of when I have a rational function, how do I know when we will have a vertical asymptote and when we will have a whole?